Hi there, I'm David Persuaville. This is Robin John, and this is Jeremy Farr. We're recording this video on behalf of University of Houston Clear Lake to present our senior projects for the spring of 2012 in the Computer Science and Computer Engineering Department. Our group has the privilege of collaborating with Dr. Dabney and other University of Houston Clear Lake faculty to develop an academic lab design kit for students to use in science and computer engineering departments. I'll introduce briefly some of the components of our experiment. We have here an apparatus that contains a strain gauge and a piezo material that provides a signal for our national LABVIEW data acquisition board. From this board, we have some software interface programs that we're using to collect information, and we'll be doing some filtering to the signals. To talk more about filtering and some of the components and the details of all these sections of our project is going to be Robin John, and he's coming up next.
Hi, just to welcome everyone that's watching. Well, basically our whole idea of this project is that we want to create a software that will actually basically provide the students with a lab kit. And what this will allow us to do is that we're actually using strain gauges to measure strain, and the students will be able to actually see the different forms of strain. You have the unfiltered, and plus you have the student version, and just a different Chevy Chef and different things that you can do to live signals that's happening. So basically how our the whole project works is that we actually attach the strain gauges as well as a piezo sensor, and it's actually being implemented through an NIOS board. And before the strain gauges actually goes into the NIOS board, we actually had amplified with 15 volts as well as V-stone bracelets inside. And so basically the whole idea is, once again, that we wanted to create a software that actually uses strain gauges and for students to create their own filter and compare it with digital versus their own design. Just to give you more about the software, we're going to turn it over to Jeremy.
Thank you, Robin. We utilized LABVIEW for our implementation from our input to program. As you can see, I have multiple boxes available on the left-hand side of the screen. You have your strain gauges, original signal, students created signal or filter, and two proprietary LABVIEW, one Chevy Chef, one Butterworth signal. The right-hand side shows the piezo sensors, input, followed by the digitally filtered Butterworth as well as Chevy Chef. I have a screenshot of our apparatus as well as the FFT. To determine your filter, you have to have the fundamental frequency, and we have utilized an FFT to show our fundamental frequency. When I start this program, you'll notice the original signals of each should be null or zero. Due to noise, you'll see some variations. But okay, Robin's going to click the device. As you can see, the signal, input signal, straight from the device is the top one. The student created one, which we're utilizing an RC circuit, as seen on the board. Very, very slightly reduces the noise. However, the fourth order Chevy Chef and Butterworth remove the noise almost completely. Same with the piezo. The original signal is kind of noisy at the tops and bottoms. Butterworth and Chevy Chef remove all noise completely. There's several other readouts on here. We have the FFT, puts out the fundamental frequency, which we're showing about 13.7. We've set the filters for about 15. Those can be easily changed in the software without any major programming skills. These two documents show the strain in which the sensors are seeing at the current time, and they'll change continuously as the program moves. I've also installed or programmed a data logging folder, so all the data that is taken while the program is running is saved to an Excel spreadsheet. You can view and see what your readouts are whenever you want to. I'm going to turn it back over to Dave, and thank you very much for watching.
Alright, well, I hope you guys have enjoyed our video, and we think it's a really good opportunity, and we're excited about our project because it's a good opportunity for students to get some exposure to design, which is something that's unique because most laboratory environments and educational environments don't provide that opportunity. So we thank you for watching, and have a good day.